Ever wondered how the heart of a helicopter, its engine, works? Does it spark your curiosity? How these extraordinary machines defy gravity and soar through the skies? Today we're diving into the fascinating world of helicopter engines and their mechanics. Helicopters are powered by specially designed engines for rotary wing aircraft. These engines, known as gas turbine engines, are the powerhouses that give helicopters the ability to lift off the ground and maintain flight. So, how do gas turbine engines work? They function on the principle of converting fuel's energy into mechanical energy through a process known as combustion. This mechanical energy is then harnessed to turn a shaft connected to a rotor system, which generates lift and propels the helicopter forward. The first stage of a gas turbine engine is the compressor. Here, air is sucked in and compressed. This increases the air's pressure and temperature, making it ready for combustion. Next, we have the combustion chamber. Here, fuel is sprayed into the highly compressed air and ignited. This results in a high-pressure, high-temperature mix of hot gases. The energy produced in this combustion process is what powers the engine. After combustion, the hot gases expand rapidly and flow into the turbine. The gases hit the turbine blades, causing the turbine to spin. This rotation is transferred to the compressor and other components via a shaft, providing the power needed for the engine to operate. Finally, the exhaust gases, after doing their job in the turbine, exit the engine through the exhaust system. In helicopters, these gases can be directed straight out through a tailpipe or used to drive an additional turbine for extra shaft power. There are two main types of gas turbine engines: turboshaft and turboprop. Turboshaft engines, which are common in helicopters, are optimized to produce shaft power. The engine's output is connected to the rotor system via a transmission system, converting the rotational motion into the lift needed for flight. Turboprop engines, on the other hand, combine elements of turboshaft and jet engines. Instead of directly driving a rotor system, they use a propeller to produce thrust. These engines can be found in some helicopters and fixed-wing aircraft. When engineering these engines, there are critical factors to consider. First, the engine must have enough power output to lift the aircraft and sustain flight under various conditions. Second, the engine should be fuel efficient to maximize range and endurance and minimize fuel consumption. Lastly, the engine must be reliable to ensure safe operation, especially during critical phases of flight. Weight and size are also significant considerations. The power-to-weight ratio is crucial as weight directly impacts performance, maneuverability, and payload capacity. Therefore, engines with high power-to-weight ratios are preferred. Additionally, due to the limited space in a helicopter's fuselage, the engines must be compact. In conclusion, the helicopter engine is a marvel of engineering that transforms fuel into mechanical energy, providing the power needed for these incredible machines to take flight. From the compressor to the exhaust system, each component plays a crucial role in this complex process. Whether it's a turboshaft or a turboprop engine, the principles remain the same: convert energy, create lift, and defy gravity.